Hello everyone, hope you all are doing well. So in this video, we'll discuss the second problem of Leetcode Weekly Contest 368. It's a medium level problem, and the first and the second problem of this contest is actually the same. It's all about the constraints. So here you have, a larger constraints, and in the first problem, the constraints are small. The problem statement is exactly same, so the same solution will work, right? If you write the solution for higher constraints, so obviously that will work for smaller constraints as well, right? So let's see what the problem statement is asking us to do. So the problem name is minimum sum of mountain triplets 2. Okay. You are given a zero indexed array nums of integers. A triplet of indices I, j, k is a mountain if I is less than j is less than k, and nums of I is less than nums of j, and nums of k is less than nums of I. Return the minimum possible sum. Now this is very important. Minimum possible sum of a mountain triplet of nums. If no such triplet exists, return -1. Okay. So you have an array like this. Okay. You have to first find triplets that are valid. What is a valid triplet? So you pick any three elements, right? They can be contiguous, non-contiguous, doesn't matter. But you pick three elements, 1, 2, and 3. Suppose you pick like this, okay? Suppose this is index number I, this is j, this is k, okay? So obviously I is less than j is less than k. In short, the middle element, that is the jth element here, should be larger than ith element and should also be larger than the kth element. Okay, nums of j should be greater than nums of I, and nums of j should also be greater than nums of k. Simple. That is what it wants to find, right? So whenever you get a triplet like this, you have to choose a triplet such that sum of these three selected elements is minimum possible sum. This is what the problem statement is asking us to, right? Because you can have multiple triplets like this, so you have to pick the one having minimum sum. Okay. Also, if there is no triplet, simply return -1. Let's look into some of the examples. So the first example, this is 86153, right? So let's see what are the triplets, valid triplets. 86153. Yeah. So can I choose this guy as the middle element? I mean, can I choose this guy as j? Let's see. Do I have any element on my left hand side which is smaller than 6? No. So that means this guy will not be acting as the middle element, right? Why I have chosen the middle element? Because one way is you pick I, j, and k. Another way is you fix the middle element, and now you find the a small element on its left, a larger element on its right. Okay, let's pick one. Can I choose one? Okay, can I choose one as the what do you call it, middle element? So do I have a smaller value on the left hand side? No. Again, I cannot choose it, right? Let's choose this one. This is index number 0, this is 1, this is 2, this is 3, this is 4. Now this is 5. That means this is acting as the jth index. Now do I have a smaller value on my left hand side? So 8, 6, 1. Yes, 1 is a smaller value on my left hand side. Okay, or rather I would say is the smallest value on the left hand side, right? So yes, 1 and 5 are satisfying the condition. 1 is less than 5. Now can I find a value on the right side of 5 which is smaller than 5? Yes, that is 3. And hence this is the triplet. This is the only triplet you can form, because if you choose this as the middle element, you do not have any element on the right hand side, right? So what's the answer? 5 plus 3 plus 1, that is 9. Similarly, let's choose here. Okay, now in this case I'll just give you one example. This is 86153, right? 86153, right? Suppose I have a 2 here. So when I chose this guy as the middle element, there was only one element on my left hand side. So the only option I was having was to choose 1. But on my right hand side, 3 is also smaller than 5 and 2 is also smaller than 5. So which one will I choose? I will choose the smaller one, because I have to return the minimum possible sum. So it will be 1 plus 5 plus 2. Alright. So actually, if you see, just while looking into the example, what we are doing, we are fixing an element as the middle element, and on its left hand side we are finding the minimum element, and also on the right hand side we are finding the minimum element. Why we are finding the minimum element? Because if you find the minimum element here, right, that is 1. Now if your minimum element is less than the element that you have fixed as the middle element, then that means yes, the condition for that mountain condition is followed, and if that is followed, I am already choosing the minimum element, and hence I will get the minimum possible answer. because I have to return the minimum possible sum. Simple, right? So wherever you have to choose triplets, right? Wherever you have to choose triplets in whichever question, just see that is it possible to fix one element as the middle element and then choose an element on the left and choose an element on the right. That is one of the easiest approach, right? That is what we'll do here. So now the question reduces to, for every element, find the minimum element on its left and find the minimum element on its right. Okay, so what I'll do, simple stuff, right? Suppose this is index number I, or let's call it J. Okay, I'll take two arrays here. Let's call it left min and right min. So for this J, left min will hold the minimum values that I have in this range. I mean from 0 to J minus 1. Left min of J will hold this. Now again, you can store it on left of J as well. It's all about indexing. Just to make indexing easier, I've done it. So that means if this is the value, if I'm standing here, so this left min of this index will store the minimum values from here to here. Why I have done like this? Because when I finally find my answer, when I go to J index, I do not have to say that, okay, I'm standing on J, so give me minimum values till J minus 1. No, minimum values till J minus 1 is already stored at this, right? So just see here, it becomes easy. Indexing becomes easy, but it totally depends on you, right? So for left min will store the minimum value from index number 0 to index number J. Similarly, right min will store the minimum value from index J plus 1 to n minus 1. Simple. Now finally you traverse and find the answer for possible answer for every index. Let's see that. The number of elements I have, answer is initialized by a maximum value. This is left min, this is right min. I filled all the values with maximum values because I need to find the minimum value, right? That is how you find it, right? Now, I is equals to 1, I less than n. Why I have started the indexing from 1? Because suppose this is my array. This is index number 0, 1, 2, 3, and 4. Okay. Now, obviously this element cannot act as the middle element because this is the leftmost element. So the first element acting as middle element will be this, right? So for this element, what is the left element? This is the only left element, right? So no need to calculate the left element of 0. It will be undefined because you do not have a value on its left hand side. So again, to reiterate, when I'm standing on index number 1, the left min of 1 will store the minimum value from index number 0 to index number 0. I mean 1 minus 1. Simple. When I'm standing at index number 3, left min will store the minimum value from index number 0 to 2. Okay. So left min of I equals to math.min of left min of I minus 1, comma nums of I minus 1. Simple. Similarly, you find right min. So 1, 2, 3, 4, 5. So this element cannot act as the middle element. This is the first element acting as the middle element, and hence we'll start from here, n minus 2. So what is the minimum? Minimum that you have calculated till here, right of min plus 1, and the number that was present here. Okay, the number that was present here, because the value that is here does not include this element. Nums of I plus 1 is not included, so that's why you have to include this element as well. Done. Now consider all the elements as the middle element. So from index number 1 to index number n minus 1, or rather n minus 2. Okay, these are the indices that will act as the middle element. So just see whether they are forming a mountain or not. So if nums of I is greater than left value on its left and nums of I is greater than right value on its right, that means, is it forming a mountain? That means I'm standing here. Whatever is the minimum value in this range, is it less than this element? And also whatever is the minimum value in this range, is it less than this element? That's why we have taken minimum value, right? If it is forming a mountain, answer equals to math.min of answer, nums of I, left min of I, right min of I. Simple. And if there is no mountain in the array, what you will do, you'll just see if your answer is still max value, because you initialize it with max value, you assign it minus 1 and you return the answer. Right now, again, you can further optimize it. We can say that, okay, instead of taking two arrays, we can just take one array, because you store left min you store right min in one array, and for calculating left min, you can do this in this traversal as well. Yes, you can do that. It's all about code readability. So this is a much better code, and you do not have to add those conditions. That's why I wrote like this. because it's much more descriptive, right? But it totally depends on you, right? So yeah, that's it for the solution. I hope you learned something new from this video. Do support it by giving a thumbs up. Do subscribe to the channel as well. Let me know if you have any other solution in your mind in the comment section. And yeah, also in case of any queries, do mention that in the comment section. I'll revert on each one of them. Thank you. Take care. Bye bye.